If you haven't done so yet, please pause the video and try this question on your own before listening on. The first step in solving this question would be to draw a simple picture that represents the information being described. The question notes that we have an electric field of magnitude 375 newtons per coulomb pointing in the positive x direction, and we have indicated that field with this orange vector, and then we have an electron situated at the origin. Now, there is a key idea that relates to electrons or other negatively charged particles placed in electric fields. And that concept is that when a negative charge is placed in an electric field, there will be an electric force acting on that charge that points in the direction opposite to the field. So if the electric field is pointing to the right in the positive x direction, then there will be a force on this negative charge that points in the opposite direction, which in this case would be towards the negative x direction. So what that means is that that electric force is going to push the electron to the left in the negative x direction, and that's going to mean that the displacement of the electron will be negative. And in fact, the question states that the magnitude of the displacement is 3.2 centimeters. So we can label the displacement as equaling negative 3.2 centimeters. Now, with that idea in mind, we are ready to solve part A, which asks us to calculate the work done by the field on the electron. So we'll need the expression for the work done on a charged particle that's placed in an electric field. So in this equation, we have the work equaling the product of the charge of the particle, the electric field, and the displacement. And indeed, we know all the values given in the question. Let's note that the charge on an electron is equal to negative 1.6 times 10 to the negative 19th coulombs. So that's the value that we'll plug in for Q. The electric field was 375 newtons per coulomb, and the displacement was given as negative 3.2 centimeters. We will have to convert the centimeters into meters. So the negative 3.2 will actually be times 10 to the negative 2. That will be converted into meters then. So we can plug in all the known values. And when you process that on your calculator, you should get approximately 1.92 times 10 to the negative 18. And the unit for work is the same as the unit for any form of energy, and so it will be in joules. So there is the correct answer to part A of the question. For part B, in order to calculate the change in potential energy, all we have to do is remember the following relationship between potential energy and work. Relatively straightforward. The change in potential energy is simply equal to negative the value of the work. So we're going to go ahead and plug in the work. And then dropping the parentheses gives us negative 1.92 times 10 to the negative 18th joules for the change in potential energy of the electron. The negative value indicates that the potential energy of the electron is decreasing as it moves towards the negative x direction. Now, since energy is conserved, the fact that the electron is losing potential energy suggests that that energy is being converted into some other form. In fact, it's being converted into kinetic energy. And so that's going to be the key to solving part C of the question. What we're going to do is take the amount of energy that was lost, the 1.92 times 10 to the negative 18th joules, and we're going to set that equal to the kinetic energy, since, once again, the potential energy is being converted into kinetic energy. So let's do that. So there we have it. The change in kinetic energy is going to equal a positive 1.92 times 10 to the negative 18th joules. All we need to do is recall that kinetic energy is equal to 1/2 times the mass of the object times its speed squared. And so to calculate the value of that speed, we can multiply both sides of the equation by 2, then divide both sides by m, and then finally take the square root of both sides so that we can solve for the speed. Now, the mass of an electron is a known value. It's equal to 9.11 times 10 to the minus 31 kilograms. So we can plug that value in for the mass into this equation, and that will allow us to solve for V. And we get approximately 2.05 times 10 to the 6th meters per second. So that's going to represent the speed of the electron. The question actually asks for the velocity. As we noted, the electron is moving to the left, and so when we describe the velocity, all we need to do is mention that the electron is moving in the negative x direction, because remember, velocity is not just the magnitude, it's not just the 2.05 times 10 to the 6 meters per second, but it's also the direction in which the object is moving. And again, in this case, that direction is in the negative x direction. So let's add that description here to get the full velocity. And that indeed represents the full velocity of the electron. As always, thanks for taking the time to watch this video. If you'd like to, please subscribe to the channel so you can stay tuned for additional videos. Also, you are welcome to send in your own question to the email address listed on the screen.